We have an example problem here. When Mars is nearest the Earth, the distance separating the two planets is 88.6 times 10 to the 6 kilometers. Mars is viewed through a reflecting telescope whose mirror has a diameter of 30 centimeters. If the wavelength of the light is 590 nanometers, what is the smallest distance that can be resolved between 2 points on Mars? Smallest distance resolved needs to take us to the equations. Theta minimum is approximately 1.22 lambda over d, and that d min, the minimum distance, is approximately theta min times s. Since I have theta min in both places, I'm going to equate these two equations together. So the 1.22 lambda over d, capital D's diameter, so the diameter of the telescope's mirror. Theta over here would be the minimum distance between the objects or points divided by s. S is the distance from the telescope to these points we're trying to resolve. And so S is this 88.6 times 10 to the 6 kilometers. Capital D in our problem is the 30 centimeters, and our wavelength is 590 nanometers. So we're looking for minimum distance. That will be 1.22 lambda s over capital D. So 1.22. Be careful with your units. Lambda, I am going to put everything into meters just so that I know what units I am ending up with. So nanometers, 10 to the negative 9. S, 88.6 times 10 to the 6 kilometers. So I need to put in 10 to the 3 for the kilo part. So I'll end up with 88.6 times 10 to the 9th meters. And then the diameter of the mirror is 30 centimeters, so 0.3 meters. Let me try that again. My answer doesn't make sense. Exponent negative 9. There we go. Now my calculator is giving me a lot of digits. I know I cannot be that accurate, so I'm going to go ahead and round. We have 3 sig figs in the problem. The 88.6 is 3, 30.0 is 3, 590, we'll go with 3 there. So 2.13 times 10 to the 5th meters, or 213 kilometers. Kilometers. So 2 points on Mars would need to be 213 kilometers apart in order to tell that there's two distinct sources of light or reflections of light from the surface. And that is assuming we have a 30 centimeter diameter telescope, which is not something an average amateur astronomer would have typically.